Good afternoon, everybody.
Good afternoon.
Guten Abend.
Guten Abend, it is not really a good day, it is.
Guten Abend, guten Tag. Hello, and welcome to this session on what's new in Windows Server 2016 Hyper-V. It's official, it is Windows Server 2016. I'm Aidan Finn.
I'm Benedict Berger. Hi, everyone.
We're both Hyper-V MVPs, and there's what, about 70 of us around the world?
Yes, I think
and
so.
There's 3 of us here in the room. So if you want to praise Hyper-V or insult VMware, feel free to talk to us. We are going to basically try do a whistle-stop tour of the new features in this upcoming version of Hyper-V. If we really wanted to get into some depth, we'd actually request about 2 days of time to go through all the new stuff that's in here. If you're keeping up with things, yes, there are going to be things missing from this list. We've kind of had to pick and choose and prioritize, so we thought we'd go with some of the more interesting things. If you want a full list of what's out there, actually there's 4 Hyper-V MVPs around, because Thomas is here as well. I forgot about Thomas. Thomas has a list on his site. I have a list as well of everything I've been able to keep up with. Do you have one in German?
In German, yes. It's the German virtualization blog on Microsoft TechNet.
Okay, so what you can get right now from Microsoft is Technical Preview version 2 or TPV2. It is not the finished product. It is quite a rough early release. Microsoft have changed how they're developing and products both for a new RTM release and also going after RTM. The best way to describe it is there will not be a finished Windows Server 2016. They're continually going to be releasing flights, like you may have heard about with Windows 10. Once the thing comes out, new updates will be adding functionality, changing functionality, maybe even removing some, who knows. So we're never actually going to see a finished product. So it's going to be rather interesting. Basically, they've taken on the development lifecycle that they have for Azure, because Azure is actually Hyper-V under the covers. It is the same Hyper-V that you've been able to deploy for the last 3 years on Windows Server 2012. It's just they've a big fabric sitting on top of it. So welcome to the era of the cloud. So when TPV2 has been out since May 5th, System Center Technical Preview is also available if you're so inclined. They will be out sometime in 2016. If I was a betting man, I would put money down on May 9th as being when they go generally available with these products. That's because the first day of Ignite 2016 in Chicago. So we'll all have some fun queuing up for dinner that day. Some of the features of client Hyper-V in Windows 10 will be covered in here, I think. There are some features in there, but they are a minor subset. Mostly we're focusing on server stuff. And Windows 10 is out July 29th. So you can reserve that right now on Windows 7 SP1 and Windows 8.1 if you want to get it pre-downloaded and ready to install when they make it available, probably somewhere between 6 p.m. and 8 p.m. local time. So, Benedict.
Let's start diving into the feature set. One of my most favorite features of Windows Server 2016 is a NanoServer installation method. It's not a special SKU, not a different product. It's still Windows Server, but it's a new deployment method. I think most of you have heard of Windows Server Core. Is any one of you using Windows Server Core in production?
That's the usual response.
Yeah, absolutely. This is 1.5 hands raised. This is typical feedback we got. And Windows Server Core most of the times feels like an unfulfilled promise. Because when we look at a Windows Server full installation, it has around 8.4 gigabytes of data. Let's have a look at Windows Server Core with removed UI. It's still over 6 gigabytes of data. Windows Server is a nano installation option. Tries to fulfill the promise Microsoft tried with Windows Server Core. It's a new deployment option. It's a headless deployment option that's still using the Windows Server kernel. But if you are finished installation of Windows Server in nano installation mode, you are finished in about 40 seconds. And you have a full data size count of 410 megabytes. So that's all you need to run Windows Server Nano. And there we are trying to fulfill the promise to just use the components we really need. You can add more components to your installation if you add more features, if you add more roles. But basically you have just the basic fabric you need to run cloud-based infrastructure. Microsoft is trying to leverage NanoServer for all kinds of roles and features, but is currently focusing on the basic cloud method. So we will see this for HyperV. NanoServer will be a great deployment option for HyperV hosts. You will see this for storage services. So every physical installation you see in a data center where you're focused on Microsoft virtualization, you really need HyperV hosts and you need some storage hosts and leverage this NanoServer installation method. Unlike Server Core or Minshell or Full UI, in the first release of Windows Server 2016, you cannot switch after the installation. So you have to choose, but then you can leverage all of the small footprint installation with you. It's not just about the size, it's about the times of reboot. Microsoft is expecting us to install reboot mutable updates twice a year. So we are talking about 2 reboots a year instead of 8 or 9 we are seeing currently with Core Server compared to the released updates in 2014. Aiden just said, well, HyperV is the same product Microsoft uses in Azure. Windows Server 2012 are the same bits Microsoft uses in Azure. This is true for most of Azure data centers, but there are some HyperV hosts. And when Microsoft talks of some, we are talking of thousands of hosts that are already running NanoServer in production. And when Satya Nadella took command at Microsoft and he said, mobile first, cloud first is our new strategy, NanoServer is a great proof of that, because Azure is running NanoServer since December of 2013. Only 2 months after the release of Windows Server 2012 R2, and now Microsoft is giving us this functionality for our own data center. Unlike Server Core, you won't see any UI, you won't see a PowerShell window. It's completely completely administrated by remote possibilities like PowerShell and a new Azure website where you can use remote components to administrate NanoServer. I really love it. I really love the small footprint, and it gives you a great fundamental for Hyper-V and scale-out services as well as born-in-cloud applications. What is Microsoft meaning with born-in-cloud applications? When you currently start developing new applications, you won't need the whole footprint of a Windows Server installation with or without UI. Just focus on whatever is really necessary and leverage the features of NanoServer. When you're currently developing Microsoft applications, have a look at NanoServer. If you're currently playing around with Hyper-V hosts, have a look at NanoServer installation options and plan before you use or install methods when deploying new hosts. Switching over to my second favorite feature in Windows Server 2016 is containers. Who of you have heard of containers before? A quick show of hands, please. Some of you have. Most of them more than from a Linux perspective. Containers are around Linux for quite some time. Most of the time I see them managed by Docker. We need to make a basic understanding here. Docker is a management infrastructure for containers. The basic technology for containers is built into the operating system. Microsoft announced a few times back that they will integrate with Docker administration for containers. Even Docker thought, okay, we are talking about managing containers on Linux via Docker on Windows, but in Windows Server 2016 we are also seeing containers on Windows. What is a container for everyone else in the room? Well, if you think of virtualization, a virtual machine things that is deployed on hardware, it has no big awareness that it's running in a virtual context. In a container context, we are sharing the operating system kernel between all containers. So we don't have a whole operating system instance in each container instance, which allows us a quick deployment. And when I talk about a quick deployment, I'm talking about a matter of seconds here. It's great for DevOps scenarios if you are now integrating and developing your applications. They're really fast spin up in new containers, but it's also a great option. I'll come to a question in a second. It's also a great option to just spin up new production services quickly. It's not a substitution for virtualization. It's a different layer of isolation. Where virtualization provides you complete isolation beneath the operating system level, the isolation of a container is integrated in the operating system of Windows Server. The nice thing, you can combine those two things. Containers are really, really great to be deployed in virtual machines. De facto, Microsoft created HyperV Container that already have built in two technologies. A container on Windows Server, it's just a new container we already know by Linux. It's also managed by Docker if you would like to. It's also managed by PowerShell if you would like to. But you don't have to create a new virtual machine and deploy a container in it. You can just deploy a HyperV container that's offering the isolation of virtualization and the new benefits of containers all in one box. So it's made for combination, and I think this will be the main use case for production environments. And Aidan and I were really happy about this feature for a whole other reason, because we asked quite some time, I have no idea how many years, but I think it's more than 5, to provide us with a feature called nested virtualization, because we are running around with lab environments, we want to spin up new services quickly, and containers are a production use case for nested virtualization. And so we are very happy, and I think most of us consultants here in the room are, that we will be able to run HyperV hosts and spin up VMs on HyperV virtualized HyperV hosts. So we have nested virtualization in Windows Server 20.
To control access to features in Azure that allows you to deploy templates using JSON that's developed in Visual Studio, so you can deploy IaaS consistently over and over and over. You'll be able to take those same things and run them against Azure Stack on-premise. So whether you want to run a private cloud or you want to run some sort of hosted public cloud, you'll be able to do that with this product. How it's going to be licensed, how it's going to be packaged, who knows? We'll find out probably next year. There is no bits that we can play with right now. They are very, very early in the development cycle. They're communicating about this product much earlier than they would have about anything in the past. In the past, you normally see it when everything's feature locked down. Now they're showing us these bits and talking about these bits much, much earlier. So it's going to be an interesting solution. It's going to sit side by side with Windows Azure Pack. So anyone who is invested in Windows Azure Pack, anyone here using Windows Azure Pack? Okay, good news, there is a version 2 coming. And that will look very Ibiza-like as well, from what I understand. But this is going to be an alternative option that does not have dependencies on System Center. It will also interact with another feature that we're not talking about in this slide deck today, which is the network controller, which is where Microsoft are taking the network fabric management pieces from Azure and bringing it down to Windows Server 2016. So you get distributed firewalling, software load balancing, working at the application layer, and a whole bunch more stuff, including support for VXLAN and NVGRE for network virtualization, all within Windows Server 2016.
I think it's very important to understand the difference between Azure Pack and Azure Stack here. Azure Pack is more like a website that gives you the look and feel of Microsoft Azure data centers for your own data centers, with leveraging existing capabilities from HyperV and System Center. With Azure Stack, you get the real software to powering up your own private or public cloud solution. So it's not just a website, it's all you need to achieve that.
Okay, some stuff in the security space.
I think it's my slide.
Is it?
It is?
Is it? Yeah, let's say it is. Yeah, it is.
Security is a very important factor for virtualization as well, but it's more important in terms for cloud, in terms for hosting, in terms for hybrid and public cloud solutions. Security and trust is the #1 blocker of Microsoft Azure, of Azure Public Cloud Solutions. So Microsoft is investing very heavily in the security stack, and I will just talk very briefly about some of the features. We have to protect from different perspectives. First, we have to ensure that our fabric is running. And since we are hosting workloads we have no control of, as a fabric administrator, we need to protect our host infrastructure. And Microsoft is introducing a host resource protection where it's recognizing misbehaving virtual machines that are, for instance, achieving DDoS attacks against our host fabric and throttling its resource, kind of a self-preservation to allow that there are enough resources available to power up our legitimate virtual machines and just drain resources from bad guest operating systems. We don't need control of the virtual machine to achieve that. We're just throttling CPU and I/O quality of service settings for the virtual machines from the outside. When I talked about new features of Windows Server 2012 R2, I think 2 years ago at E2E, I got some bruise when I announced support for secure boot for Windows virtual machines, because there were some Linux fans in the room that said, well, I can't boot my Linux VM on HyperV anymore. Well, then just disable secure boot, and with Windows Server 2016 we will get secure boot support, so we can sign our kernel to make sure the operating system is unaltered at boot time for Linux, supported Linux guest operating systems as well. And I have talked back to those guys, and I really received great feedback, because they said, well, we don't have to hand in all our versions to Microsoft to get them signed. They are very efficient and easy in the process of allowing secure boot enabled for supported Linux operating systems. My most favorite security feature in the next version of HyperV are shielded virtual machines that change the way cloud computing will be accepted, in my own opinion.
And that includes Azure, potentially.
Yes, this is the Azure enabler. Because trust is a problem we all have, especially in Germany. That's why this conference is happening in Germany today, because we are having so many trust issues around public cloud solutions here. The shielded virtual machines, we take away the possibility for the Fabric administrator to access any kind of data from within our virtual machines. We have a hardened hypervisor that's taking away some comfort features I will go into a second, to allow that only the owner of the virtual machine sees, knows, and can tamper with what's happening inside of a virtual machine. As of today, and this is true for all hypervisors we are currently seeing in the market, you are trusting your host administrators, your Fabric administrators, where you place the virtual machine, because they have control over network, because they have control over storage. Currently you can take a virtual machine, copy it, and mount it somewhere else. You have time enough to decrypt it if it's using BitLocker to achieve the keys, and whatever you can do. With shielded virtual machines, we have a guarded Fabric infrastructure that allows us to power up virtual machines only on trusted HyperV hosts. A trusted HyperV host is validated in 2 ways, an easy one and a secure one. Let's talk about the easy one first. We have a called host guardian servers. That's a different HyperV host that's hosting its own Fabric Active Directory, where the BitLocker keys are stored, and where we have an Active Directory group that all hosts are member of, that are part of our secure HyperV infrastructure. When a virtual machine is powering up on a HyperV host, it's checking if the host you are trying to run this virtual machine on is a member of this Active Directory group, and is ensuring some kind of security that this virtual machine is not stolen to recover the BitLocker keys to decrypt the operating system and its data. It's not a perfect security approach, but it's very easy to achieve, and it runs on today's hardware, and it's better than anything we have currently in the hypervisor. Only thing required is Windows Server 2016 and another Windows Server 2016 HyperV host that runs their host guardian service. To make Aiden happy, you don't need System Center to achieve this scenario. To make it really secure, we have to do some kind of investments, and I think hosters, public cloud providers will make this investment, because this is a great service we can provide to customers. We need some hardware requirements, because now we are bringing in hardware assisted security into play with TPM 2.0. Quick question, who is currently using server systems with TPM 2.0? Quick show of hands.
That's the correct answer.
That's not a surprise to us, because we haven't seen any server system in the market with this security set. So this is an investment in the future. This is seeing what we will release a lot of TPM 2.0 capable servers when Windows Server 2016 will be released next year. So this is nothing we can play around in a real security manner in lab environments today.
You can do it with laptops. I think some laptops.
Yes, you can do it when you buy a modern laptop and run HyperV on it. You can create a lab scenario, and you can also play around with virtual TPMs that don't offer the same level of security but give you an idea what's happening here. But when you invest in this infrastructure, and Microsoft recommends to have at least 3 HyperV hosts running the hosted Guardian servers, each hosting its own Active Directory and storing the keys, and the keys are saved on the TPM, and you also have most of the time hardware-assisted security module that is storing the certificates. The certificate storing in a special hardware appliance is handled very well, better than in a software stack. And this gives you a security that also controlling the boot process of the virtual machine, the storage process of the virtual machine, and all kind of data encryption is controlled by this hardware-assisted setup. So when I place my virtual machine there and started, it's communicating again with our host Guardian servers, it's accessing the keys from our TPM chip, it's accessing the certificate store to make sure, okay, this virtual machine is running on a trusted host, it's not been tampered with, and it's booting the exact way I'm expecting to. And then I can be sure that there is no one tampering with this virtual machine. I can make sure that there is no one stealing data out of my virtual machines. There are some caveats to that. We are taking control of the fabric administrator. There is no more remote console from a host perspective to console into the virtual machine. There is no VM bus. There is no special comfort features like file copy from outside of the virtual machine, because Microsoft wants to assure 100% security. And with this level, we can assure this security, and I think it will enable cloud adoption, especially in countries like Germany, even faster. Quick question. Who has the private key? The TPM and access certificate
HSM.
that are running in the HSM. It's a small hardware module that is attached to your server that is storing the private certificate. It's nothing you typically see in servers today. That's why I said there is a special investment.
Okay, but the problem with this is always, if I'm not in charge of my private key, it means only I have a private key in the hand. Everybody has a key. Who physically can come to the key.
Yes, you need to physically protect your server systems, but you are putting a security layer between your HyperV hosts and the hosted Guardian servers. It's in a different HyperV host, so you need to access both ways, and you have to ensure physical security of your data centers. Yes, but you can put a division into that. There was another question, I think, here somewhere. Okay, just step up back later. So we're done with security and moving on to storage. Aidan, your special area.
Storage, so some fun. So HyperV Replica is one of my favorite features of HyperV because it makes DR possible for everybody, especially when we start coupling it with Azure Site Recovery, which made some significant improvements last December by removing its demand for System Center, meaning in small, medium enterprises, not just the large guys, could start replicating into Azure. And as I've heard now, that market in Azure is actually dominated by the small, medium enterprise. But one of the problems we have with HyperV Replica is it's very rigid. And Microsoft are working based on feedback to make HyperV Replica more flexible. So one of these things is the ability to hot add a VHDX to a virtual machine that's already being replicated, and then opt in that virtual hard disk into the replica set. So that will make things a bit more agile and flexible for businesses. When Windows Server 2012 was released, it came with storage QoS. However, it was a limited form of QoS. It was managed on a per VM basis or a per virtual hard disk basis. We were allowed to set minimum rules and maximum rules. A maximum rule would cap the amount of IOPS that a virtual machine or virtual hard disk could create or generate. The minimum rule created an alert that's buried in WMI and would not enforce an SLA on that disk. The fact that it wasn't distributed meant that there wasn't a central point of management for QoS. So for someone who was operating a larger deployment, a large enterprise, or a hosting environment, very hard to control and manage. It was done very much on a one virtual machine or one virtual hard disk basis. It wasn't a policy system. So Microsoft are changing that with Windows Server 2016. It is an evolving piece of technology. Initially when they started talking about this, they said this was something that would only work with a scale-out file server. And the scale-out file server would be the point where we manage and control the IOPS policy. But now since Ignite, we've learned that this is something that they're also going to support with a SAN. So it's going to be interesting to see how they implement that. They haven't talked about how they're going to implement that. It seems to be something that's very early in its development. But we're still nearly a year away from release. So it'll be interesting to see how this works. We can configure maximum minimum rules on disks, VMs, or tenants. This now, when we're doing this at a central point, we're now going to be able to start creating policies. So saying that a virtual or a particular client, a department, a customer, or whatever, is going to be allowed to have a certain number of IOPS. And they're going to be guaranteed a minimum level of IOPS. And there's different ways we can combine those minimum and maximum rules to have different effects. So for example, we might have minimum and maximum be the same thing. So we can get the same sort of performance guarantee that you get in Azure. When you deploy a virtual machine in Azure, you're guaranteed that if you deploy a basic virtual machine, you get 300 IOPS per data disk or 500 IOPS per a data disk in a standard virtual machine. And we can do that sort of thing in Windows Server 2016. But one of the most interesting things is Storage Spaces Direct, called S2D for short. It was going to be called SSD2, but it turned out that was some sort of negative tax connotation thing in America, or death thing or something like that. So they went with S2D, which, if you say it really fast, sounds almost like STD. I'm just after realizing that. So storage spaces, if you've come to previous E2E VCs or pub forums, you'll have seen people like me and Carson Rackval and Michael Ruffley talking about storage spaces in the past. And the concept here was we have a bunch of JBODs, just a bunch of disks. Cheap, affordable enclosures with SSD and HDD disks, bringing down the cost of storage compared to a SAN, fronted by 2 or more file servers, and sharing that storage to HyperV clusters using SMB3 networking. And Microsoft looked at this and said, you know, it's fantastic and everything, the concept works. I've got customers that have over 1 petabyte of raw storage in 16U. So one in particular is 1.4 petabytes in 16U, and they got that about a third of the cost of the equivalent NetApp, which they dumped. And I have another customer in the UK that has bought, geez, at this point probably about 40 or 50 JBODs, dumping 3PAR, because the price per gigabyte was just way lower, and they were getting the same levels of performance. And Microsoft looked at it and said, you know what, we can make this even cheaper. Because the JBOD stuff requires SAS. It's an extra layer of hardware. Why don't we bring that into the servers themselves and enable support for SATA disks, traditional SAS, and NVMe. So these are non-volatile memory express units, basically things that sit on a PCI card with no SAS controller. Very high speed storage with low latency. Now there's 2 deployment models. Let's focus on this one here first. This is where we have HyperV clusters, traditional cluster or standalone hosts or whatever. And then down here we have a scale-out file server cluster. In the past, we would have had a layer of SAS JBODs down here. Instead, these servers are aggregating their internal disks and doing storage spaces across those internal disks. SATA disks offering incredibly low-cost SSDs. Sort of SSDs that cost 150 euros in your corner store. Or NVMe, so if you want peak performance on low latency, and then present all that storage to these HyperV clusters using SMB3 networking, possibly with RDMA, so we get ultra low latency there as well to make the most of those NVMEs. And then Microsoft thought, you know what we've got here is a cluster, a highly available cluster with cluster storage. What about we do a hyper-converged deployment? So we have all of the roles, failover clustering, scale-out file server, and HyperV running on one tier of hardware. So with Storage Spaces Direct, you're going to have 2 deployment models. The converged or disaggregated model, where you've got the HyperV clusters on one tier, and the scale-out file server cluster running on another tier using internal disks. Or the hyper-converged model, where you're able to guarantee that your storage and your compute scale at the same levels. Because that's the gotcha with hyper-converged. That if you need to increase the amount of storage, you're also increasing the amount of compute and the amount of licensing that goes with that compute. And that isn't a model that suits everybody, but it's a model that suits some organizations who have very predictable levels of growth. Distributed Storage QoS allows us to implement policy on the scale-out file server and somehow later on with a SAN. And we apply that policy using PowerShell or System Center. And then there's a communication path using a protocol called MSSQoS. between I/O scheduler on the scale-out file server and the rate limiters on the HyperV cluster. And this allows us to create policies for disks, virtual machines, or tenants on the scale-out file server, and that will be applied by the hosts to guarantee virtual machines or disks or customers a minimum amount of IOPS or a maximum amount of IOPS.
Let's talk about availability. What Aidan just showed us about storage is a great fundamental shift in the storage architecture. When every one of us deployed SANs, expensive SANs, until 5 years ago in our data center, we are now seeing very great alternative to that. And now moving on to hyper-converged solutions, that's the one I really like, what makes this even more possibility. Availability. Microsoft has done a lot of work to make clusters more resilient, and I won't go into the technical deep dive of that, but just mentioning some examples. When we have a situation that we have never saw in the past, like a crashed cluster service. Anyone experienced a crashed cluster service? Never of us. Virtual machines running on this crashed node would immediately be failed over, so we would experience the downtime of our virtual machines. Now we have control over the failover behavior on these virtual machines. We can switch our hosts with unexpected behavior into an isolation mode where it won't be joined into the cluster back again but still running its workloads, or where it will be in a quarantine mode where the workloads will be drained from these hosts and run on another host as well to continue the service operation of these virtual machines. My most loved cluster feature is that because other virtualization guys already helps us, is the possibility to have an increased storage resiliency. When we have a loss of storage connection through our virtualization hosts, virtual machines won't crash anymore. They won't run into a blue screen. They will be automatically paused for a matter of time we can control. It's currently set to a minute, and then will be controlled, resumed when the storage connectivity comes back into this time frame. Currently with Windows Server 2012 R2, if we lose our storage connectivity and doesn't care if it's block storage or file storage or virtual machines, will blue screen immediately. This behavior will stop at Windows Server 2016. One of the most biggest announcement around cluster in Windows Server 2012 and 2012 R2 was the shared VHDX, where we have virtual disks that's connected to multiple virtual machines to ensure guest clustering in a more easier way. We don't have to use our iSCSI connections from within virtual machines. We don't have to use virtual fiber channel to connect multiple storage unit to multiple virtual machines. We can just use a standardized HyperV virtual hard disk. I really like the concept of that, but it had a major drawback in Windows Server 2012 R2. It didn't allow for host-based backups. And 95% of the backup solutions on HyperV IC are host-based, and so you had to manage for another reason, another tool to utilize backup for shared VHDX files. And I'm very happy that this will stop. Shared VHDX for guest clustering will be now compatible with all the backup solutions, the security solutions, the monitoring solutions we see. It's now easier to identify a shared VHDX file through a special file format, and it's now easier to maintain. And in my personal opinion, we will see an increase of deployed HA solutions as a guest cluster inside of a virtual machine, because it will now be easier to get there. And easier to get to a high availability solution is a very great step and will give us increased agility.
Oh, jeez, what a handover. People have been using, hopefully, dynamic memory since Windows Server 2008 or 2 SP1, where they're able to optimize the amount of memory that's allocated to a virtual machine. And that's great for a lot of workloads, but typically when we start getting to bigger workloads, dynamic memory has a limitation, which is when we create virtual machines that span the NUMA node of a physical host architecture, we start getting inefficiencies in how that virtual machine will perform because it's spanning NUMA nodes. So there's an inefficiency between virtual processes and virtual memory within the virtual machine and how it's mapping versus the motherboard. So typically with those large workloads, we enable static memory, which means we have wasted memory on those hosts. we don't have the ability to adjust the way we would like to. So what we're getting in Windows Server 2016 is the ability to dynamically resize memory on static memory virtual machines. So we can manually go in or create automated processes that will resize the memory of a virtual machine. So we can increase it or decrease it. Obviously we can't decrease it below what it's actually using, and that would be a bit silly. But we can start, being able to be more dynamic and more flexible with our workloads. So if we find a virtual machine that's underusing memory, we can reduce it. If we find a virtual machine that needs more memory to get the workload performing to peak levels, we can increase it. We'll also get access to some of the dynamic memory statistics for those static memory virtual machines so we can perform this work with some intelligence. One of the big features of Windows Server 2016 is going to make it easier for people to deploy Windows Server 2016. If you've got Hyper-V clusters, when you've been faced with a new version of Windows Server, you have had to go through a rather painful process of draining nodes or virtual machines from a node, removing that node from that old cluster, and building a new cluster with that node, and then moving virtual machines using migration wizards or cross-version live migration to that new cluster. And I know for a fact that when a lot of people were faced with that project or that deployment, they said, you know what, let's leave Windows Server 2008 or 2 there, and when we need to start growing capacity, we'll build a new cluster with Windows Server 2012 or 2012 or 2. And they kept a lot of that old stuff. Microsoft wants people to be on the current versions of Windows Server. You're buying the licensing, you might as well use it and take advantage of some of the features. They want you up there. So they have an easier support life as well. They want to reduce the cost of their support. They don't want to be looking after older versions of Windows Server. So what we're getting is rolling cluster upgrade. And this is the ability to take an existing Hyper-V cluster or Windows Server cluster and do a sort of in-place upgrade of the nodes in that cluster. Now we're not actually doing an in-place upgrade of the operating system. We're removing the machine from the cluster, rebuilding it with a new version of Windows Server, and adding it back to the old cluster. So we have no downtime for our services. So I wrote some pseudocode to try to explain the whole process. For each node in the cluster, we're going to drain that node of virtual machines using live migration. So no downtime to virtual machines. Then we rebuild that node from Windows Server 2012 or 2 to Windows Server 2016. Then we take that cluster node and we add it back into the old cluster. So now the cluster is running mixed versions. It's running 2012 or 2 and 2016, but it will only operate at 2012 or 2 functional level. They've effectively copied how Active Directory works. So we have different versions of functionality. We can test that node and then we can put it into production, and we repeat that process for every node in the cluster, and then we can upgrade the cluster version level using a single PowerShell commandlet, upgrade cluster functional level, bring it up to 2016 functional level, and then we can upgrade the versions of the virtual machines. Now Microsoft are making it clear that virtual machines actually have versions. I think this is version 6.
Yes, it is.
Version 6 that we're going to. So, very quickly.
Now we're coming to the last slide with features, and I really want to go to the comfort of administration. There are two main aspects I want to show improvement of. With Windows Server 2012 R2, Microsoft announced the capability of copying files into a virtual machine we don't have network connectivity to by utilizing the VM bus. The same capability is utilized in Windows Server 2016 to giving us PowerShell Direct that enables us to execute PowerShell commandlets inside of a virtual machine we don't have the need to having network connectivity to. It's also using the VM bus. It's using the HyperV integration services to communicate within the virtual machine. That makes central administration, if you're controlling the host fabric and the virtual machine, a lot easier. My favorite feature of administration features in Windows Server 2016 is the capability of upgrading the Hyper-V integration component through Microsoft Update and Windows Update. Who has currently a good solution in place to upgrading integration components of all the virtual machines in Windows Server 2012 R2? I feel one hand, it's a lot of manual work to have those scripts created and executed, and with Windows Server 2016 we will just run Microsoft or Windows Update because we need it anyway, and all our integration components, even for legacy operating systems older than Windows Server 2016, will get update automatically through our existing update capability. So there is a whole part of HyperV administration that's just phasing out because we don't need to worry about it anymore, and I really love that because we are all lazy administrators.
So that's everything we're covering. If there's any questions, Corner, Benedict, myself, Didier over there in the front row, or Thomas Maurer, who is somewhere wandering about, and we'll be happy to discuss any questions you may have. Thank you very much.
Thank you, everybody.